Hello, assalamu alaikum. Hello. Hello, can you hear me?
Walaikum salam wa rahmatullah.
Okay, so how are you?
I'm fine. How are you?
Yeah, Alhamdulillah, I'm fine. Thank you. So Ramadan Mubarak. Okay, so
Ramadan
basically,
Mubarak.
we'll start our first session. Okay, so basically, you want to learn about that how we can easily make the land use and land cover classification using machine learning method. Okay, I already complete your work, and in this time I will show you one by one, explain all of code. I hope you can easily get it how it will be work. Okay, as well as I also send
Okay.
you this code, and also send you this recorded video class, also send you, so that you can also practice for the next other place also. Suppose when you learn these things for one place, then you can easily implement this knowledge in the other region to make the land use land cover classification map. Okay, so let's go. Just I
Okay.
simply share my screen. Okay, just let me share. Okay, can you see my screen?
Yes.
Okay, so let's go. Okay, so basically you can see this is the work we already done. First of all, I try to show you the result. Here you can see basically this is our satellite images, and these satellite images in this time, uh, what's the time about the satellite images? It's very important. In this time we can take the image for 2003. Okay, from 1st January to December. Okay, so this time period we can get this type of satellite images. Okay, basically just I simply
Okay.
open this map. So this is our satellite images for your study area. Okay, so further we are applying the machine learning model, and then we are classified this type of classes. Here you can see this type of red color. Red color mainly it's identify the build up or settlement. It can be road, or it can be any kind of house or industrial, anything about the build up or settlement.
Yes.
Red color identify about
Yes.
that, and this type of blue color identify about that water body, as well as also you can see this type of green color, it's identify about that vegetation. Okay, and yellow color
Yes.
identify about the barren land. Okay, so actually there is no
Yes.
nothing about the build up or water body, it's totally a barren land or fallow land about that, so you can get this type of yellow
Right.
color barren
Right.
land. Okay, so this is
Very
our
good.
map, land use land cover map. And also you can see about that accuracy, about that what the accuracy you can get from this machine learning model. Here we find out the 93% accuracy. Basically it is the overall accuracy. Okay, so how I can calculate the accuracy I also explain later. Also we can get the 91% accuracy, it's called the kappa accuracy, kappa coefficient or kappa accuracy we can also calculate. As well as we also calculated the area in this type of bar column chart. It show about the water how much area, basically it's a square kilometer result. Also you can see the vegetation how much area, also you can see about the barren land how much area, also you can see the build up how much area. So whole things I will explain one by one, so I hope you can easily learn about that. So first of all, here you can see you can send me a boundary shape file. Okay, so you can send me a boundary shape file. So basically this boundary shape file I need to import in my Google Earth Engine platform. I need to import it, this shape file. So now arise a question how I can upload the boundary shape file. So this is your boundary shape file you can send me. Okay, so this shape file I just simply import in my Google Earth Engine. So how I can import? For that, you can see a tab, asset tab. Okay, asset tab. So you can simply click on the asset tab and go to the new folder, and you can just shape file. So mainly when you want to upload a shape file, you need the total 4 file: SSP, SSX, DBF, and PRJ. These 4 file make a one shape file boundary. So you can simply click on here,
Yes.
and you can get the source file. In this time, you can simply go to your local storage, mainly your PC, where you put your shape file. So I already download the shapefile from my email. So just I try to open it and show you that. I stored this shapefile. Okay, let me open this folder. It will be stored in the where is it? Download folder, I think. Okay. Or let me show you the another shapefile. In this time, I think it's my another laptop I also use in here. So for that, suppose any shapefile, all shapefile you can easily upload, no problem. Suppose you want to upload this, and I show you the another shapefile. Just a minute. We saw you store it in here. Where is it? Okay. So here you can see it's a one kind of shapefile. Suppose Dhaka city shapefile. Here you can see. So in this time here you can see this shapefile. Suppose Dhaka, you can see DBF, PRJ, SSP, and SSX. Okay. So this shape, when you import any shapefile in Google Earth Engine platform, you must need to select DBF, PRJ, SSP, and SSX. This 4 file you can simply select on your, then click on the open. Click on the open. So now you can see it will be show this type of things, and further you are just click on the upload option. Click on the upload. In this time here you can see our task tab will be running, and now it show you that you can see now it starting the uploading. Okay, and it also show you that how much time you need to complete the upload. You can see now it is starting. Okay, you can see it loading. Okay, so it takes some 1 minute or 2 minutes for uploading this file in Google Earth Engine platform. And when it will be upload, you can simply click on here. You can see it's called the refresh. Refresh. When it will be finished, you click on the refresh button, and then check the file name. Simply check the file name. Basically, Dhaka, it's my file name. Okay. So after finishing this loading, simply click on here, refresh, and then find out this file name, Dhaka. So you can see it will be loading in this time. Okay, we are just waiting 1 minute. Then it also you can easily understand about that. So same process I also do for your shapefile. Okay, just I simply go to the asset tab and then simply import SSP, SSX, DBF, and PRJ. This 4 file I simply import. You can see it will be finished. We can get this type of sign. Okay, so now further click on here. You can see it's called the refresh asset. So click on here. Okay, it will be, you can see loading. Okay, now further click on this folder. Here you can see I can get a Dhaka. Okay, so basically now this shapefile is stored in here. So just I click on here, and you can see now it show my boundary shapefile which I uploaded in my Google Earth Engine asset. So further I can use it to make the land use land cover map. Okay, so just I simply click on the import. Click on the import. You can see it's imported. It show the table. Okay, I simply rename it as a ROI. Okay, so table I simply change it ROI. Okay, so this is the process for the first line of code. Okay, so when you do for the any new region, first of all you just simply import your boundary shapefile and click on here, and then further import. Okay, after importing you can put any variable name. In this time I put the name ROI. So here you can see I put the name ROI. Okay, so basically this ROI is stored my boundary shapefile. Yes,
Region of interest.
yeah, region of interest, or you can put any name, no problem. I put the ROI. Okay, in this time this shapefile, basically this is my shapefile, boundary shapefile. This shapefile I store it in the ROI. Okay, ROI is a variable, or you can also say it's a folder name. It's a folder. Suppose it's my folder name. This folder I stored this shapefile. Okay, ROI. Okay, it's done. So now after doing this ROI, I put my ROI, and now further what I do in this time, I want to find out my image collection. Okay, so how I can get the image collection? Basically Landsat 8, Landsat 9, Landsat 7, Landsat 5, or any kind of image collection. How I can find it? So I can simply click on the search bar. Here you can see the browse data catalog. Simply click on here. So now it will be open all of those data set in the Earth Engine public data catalog. So from here I want to choose for Landsat. So just click on the Landsat. And here you find out all of Landsat image collection, mainly Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5, and also see about the time period, So which time you want to need, you can simply check your time and then work with that. In this time, you want to work for the year of 2003. So here you can see, year of 2003 will be cover the Landsat 5. Okay, when I use the Landsat 5, or Landsat 7 is also work. In this time we are just work for the Landsat 5 because you can see it belongs with 2003. We can easily get the year of 2003 when I use it. Okay, so for that I just click on the Landsat 5 because it cover my time period. And here I can get this type of image collection, top of atmospheric, raw image, and also get the surface reflectance. So basically for the land use land cover classification, we are use here the surface reflectance, this satellite image all time. Surface reflectance satellite image will be used for making the land use and land cover classification map. We can get the better result. So for that I just simply click on here. So now I can get all of this information about the Landsat 5 satellite imagery. So here you can see we can get the time period about that. Basically we can get the image from year of 1984 to 2012. This time period we can got the image using the Landsat 5 satellite imagery. And you can see the dataset provider, mainly it's the USGS, mainly United States we can get this dataset from here. And you can see the Earth Engine snippet. So it's very important. It's called the unique ID of this dataset. It's a unique ID of this dataset. Okay, so it's we need this unique ID. So you can simply copy, just simply copy. Okay, this unique ID simply copy from here, copy, and then paste here. Okay, simply paste here this unique ID and give a variable name image. So in this time I create a new folder, suppose image. So this image collection I want to import in this variable or folder name image. You can put any folder name, you can give any folder name or any variable name you can put, no problem. So just I simply copy and paste here. Okay, and you can see this image collection provide you the image from this time. But in this time I need the image for a specific time, year of 2003. So for that I just simply use a filter date function and put my start date and end date. Okay, suppose I take 2003, all of images I consider from 1st January to December 31. I consider all of those images, and this image I want to need only for my study area, my region of interest. Okay, so for that I simply use the filter bounds function and call my folder name ROI, mainly region of interest. I need the image only for my boundary, not for whole world. I need only for my region of interest. So for that I just simply use here the filter bounds function and put here the ROI. ROI basically it's my region of interest, it's my boundary shape file folder name. Okay, just put here the ROI. Then I don't need all of those images. I need only for this image which image is the less than 1% cloud cover. Okay, so in this time I always try to find out the lowest cloud cover image. Always I try to find out the lowest cloud cover image. So in this time I just use the filter metadata function and call the cloud cover less than 1. In this time it consider only less than 1% cloud cover image. Okay, so in this time here you can see the full things is stored in this variable image folder. So all of those things I stored it in the image folder. Okay, so what can I do? This is my image snippet ID. So basically this is my ID name. Okay, and this image for the this time period, all of time period, but I need only for the year of 2003. So just I simply use the filter date function and put my time period. Then I simply put the filter boundary, mainly filter bounds. I simply put my study area which is ROI. Further I choose only for those image which image is the less than 1% cloud cover. So this is my image. So now I check how many images I can got. So for that suppose I just use here the print function and use here the image and use the size function. Okay, so in this time click to the run. In this time you can see it loaded the result how many images are available for my study area in year of 2003, which is the less than 1% cloud cover. It show the result again. So you can get the 20 images. Okay, we can find out the 20 images are available for this study area, which is less than 1% cloud cover and also available between this time period. Okay, so in this time, this 20 images I want to use and create the median composite. What is median? In this time, I use the total 20 image collection and then I try to calculate the middle pixel value of each image and make the composite. So for that, okay, I will explain the later about this code. So for that, you can say I simply use the median function. Okay, so I call the image and use the median function and clip with my study area. Mainly in this time I use the clip function to with my study area. And also you can see in this time we can get this type of code. So basically this code we are used for making the scale factor. Okay, scaling factor. So basically it's not much important. Okay, basically in this time it's very easy. Just use the map function and call this function variable name. Okay, this code is the same all time. When you want to work for the other, it's same. It's just is it used for scaling factor, basically reflectance wavelength. So for that you can see I just simply call the image and then simply call the image map, simply call this variable name and use the median and clip with my study area. Okay, so further I want to show the image, so I explain later about this code. I will explain later. So in this time I just simply show the result. So for that I simply I want to show the visualization. Suppose red, green and blue for Landsat 5, B3, B2 and B1. And then I map.add layer and call my image visualization parameter. So further you can say I can get this type of true color composite. Okay, so in this time SRB3, it's a red, it's a green and blue, mainly RGB, red, green and blue. Then I can get the true color composite. This type of image I can get. If you want, you can also change the band combination. Suppose you are just simply click on here, and now you want to put the another band combination from here. Suppose I set the band combination near infrared, then red, and put here that suppose green, blue, and now stressing 98%. So now we also get the another band combination from our satellite imagery. So you can say I can get this type of, it's called the false color band band combination, false color band combination. So in this time here you can see from here I also change the band combination. I can use different types of band combination. Suppose I just choose about that, suppose B5, then put here the B4 and put here the 98% apply. So in this time you can say I can get the another band combination. You can say I can get the another band combination, then I can get this type of feature. So it also important because using the band combination we can easily identify for the different types of feature from the satellite imagery. So in this time when I use this band combination, then I can easily find out the vegetation. You can see this type of green color identify about the vegetation. Water body show as a black color when I use this band combination. As well as we can easily get this type of barren land as a gray color. Okay, we can get this type of color. So using the band combination we can easily identify the different types of feature from the satellite images, and it's also very helpful for collecting the training sample. So in this time you can see here we can get the image. Okay, so we can get the image look like that. So this is our image we can get. In this time I want to apply the machine learning. Mainly in the machine learning basically we can get the two types of machine learning. One is the supervised, another is the unsupervised. So mainly supervised machine learning, when you apply you must take the sample data. Okay, we need the sample data. When you want to apply the supervised machine learning, you must take the ground sample data. So in this time how I can collect the training sample? In this time suppose I want to classify water body, build up, vegetation and barren land. So I need to take the total 4 samples of each classes. So for that how I can collect? So for that you can simply click on the you can see the add marker option, add, and here you can see, and then simply click on the setting properties, and further you can put the name. Here I already put the name water. Okay, class property class, and set the value for 0. Okay, and then you are just simply click. Suppose I just simply click on here. So just water body, you are just simply click this type of sample, training sample. Do for the same for vegetation. So just take the new layer. Okay, click on the new layer. It will be show the geometry. Simply click on here. You can put the rename as a vegetation, and then feature collection. Click on the property. Put the property name as a class. Property name will be same. Okay, then set the value for 1. So in this time, same things I also do in here. Suppose click on here, you can say I put the vegetation, then property is the class, value is the 1, then okay. And further, I just simply choose only for the vegetation. You can see I just simply take the green pixel value from here. Okay, it's a vegetation. I take the training sample of vegetation. Okay, after the same process for build up. Okay, in this time for the build up, you can also use the another. Suppose you want to put the true color composite. Suppose I put at the red, then green and blue for Landsat 5, then apply. So now I can easily find out the build up. In this time, this type of region, basically you can see, you can also zoom it. Basically, you can get the white color pixel, mainly white color pixel. It's identify about the build up region. We can easily collect some white color pixel from here, as well as you can also open this satellite.
Barren land, not build up. Barren land.
Yeah. Oh, it's a barren land. Sorry. It's a barren land. Okay, sorry. It's a barren land. So for the barren land, here just use another combination. Suppose it's very important for the barren land. It's called that band 5, band 4, and band 2. Apply. So in this time we can get that this type. Yeah. So in this time here you can see this type of color, grayscale color. It's identify about the barren land. Okay. So it show the barren land. We can easily get this type of color. This type of color you can consider as a barren land. Okay. Just simply take this type of color as a sample. Barren land. Also you can see this is the barren land. Just take this training sample on this type of color. Okay. Grayscale color. It's a barren land. Okay, and further finally suppose urban. For the urban, it's very useful for use the true color composite. Mainly it is the red, then green and blue. Okay, apply. So further you can easily get, you can see here from this image we can easily identify. Suppose it's a build up. Okay, you can simply zoom. We can get this type of color, white color pixel. You can see it's a white color pixel. So it must be settlement. Okay, you can see it must be settlement. You can see we can get this type of settlement. When you use the red, green, blue, this type of white color pixel identify about the urban or build up. Okay, so you can simply take this training sample and also try to find out this type of. You can also see here it's a this type of pixel we can get. White color pixel we can easily consider as a build up or urban.
Go to the center of the city. Go to the center of the city, center of the shape area, near to the river.
Yes.
Up.
Yeah. In this time, we can see there's a lot of urban. Okay. There's a lot of urban. So you can simply take this some training sample from here, and we can easily get. You can see when I classified, we can get the lot of red color pixel from here, because it's a lot of build up area we can consider from here. Also, you can see we can take the some training sample. Okay, which is more reflectance. Okay, we can take the urban training sample. Okay, you can see this is the urban training sample you can take from here. Okay, it's the urban. Okay, so after taking this training sample, what can I do? After taking this training sample, we are just simply merge all of those variable. Suppose you can see water merge with vegetation, merge with barren land, merge with urban. Use the same name: water, vegetation, barren land, urban. So water merge with vegetation, merge with barren land, merge with urban. We are just simply merge all of those training sample and store it in a one variable, samples. So now when I print that, then I can get the result how much training sample I collect for all of classes. All of classes I collect 301 training sample total, 301 training sample. And also you can see the feature. You can easily get the pre-categorized. Suppose this training, what's the class? You can simply click on here. You can see we can get the properties I can get the class 0. And what's the class 0? Class 0 mainly water. Also you can see, click on here you can see about the property, we can get the 0. So this 14 training point is also used for water. Also you can see this type of sample, what's about that class 1. So this training point I use for make the pre-categorize of vegetation, because you can see I put the value for 1 for vegetation. So in this time we create our pre-categorized data. Okay, it's called the pre-categorized data. So you can see this training sample is the class 2. So basically this is the barren land. Okay, so in this time we make the pre-categorized data. All of those things we make the pre-categorized data. So now I want to create the spectral signature. So a spectral signature means that band's value. Suppose here you can see all of those training sample, I want to extract the band's value. Suppose for this point, what is the band value for B1, B2, B3, B4, B5, NDVI, MNEWI, BSI? So what's the value? What's the pixel value for this location? For this point, what's the pixel value? I want to extract all of those pixel value. Okay, suppose here I can find out total 301 sample. Okay, so I want to extract the 301 samples, all of those bands value, I want to extract from here. Okay, so I just simply make a list about that SRB1, SRB2, SRB3, SRB4, SRB5, 6, and I also add the some external band. Here you can see I add the NDVI, NDBI, MNDWI, BSI. So this type of external band I also add in my model. So that's why I also get the more better accuracy. Okay, so basically in our satellite image you can see it's only available for SRB1, SRB2, SRB3, SRB4, SRB5, SRB7. Only available this type of band. But I also add this type of external band, NDVI, NDBI, MNAWI, BSI. So that's why my model give me the better result. I can get the better accuracy when I use this type of external band, NDVI, NDBI, MNAWI or BSI. So for getting the better accuracy, I also use this type of external band. So that's why all of points also extract the information for all of band. Okay, so now how I can extract the information? Very easy. Image. So basically what is the image? This is the image. You can say I already defined the image in here. So it stored this satellite image. So I simply use here the image select band. So in this time you can say I make a folder or make a variable and store all of those band in this folder. So I call the image and select all of bands. Basically it's stored all of bands, and then use a function sample regions. So this function help you to extract the band pixel value. Okay, and you can see here you can get the collection. Mainly here I can get the samples mainly total 301 samples. Okay, and property mainly it's the property name which you put in here, class. So just use here the class properties name, and scale is the resolution of your satellite images. So now print that. You can see here all of training sample, extract the spectral signature. Here you can see, click on here, you can see it extract the all of value, SRB1 value, SRB2 value, SRB3 value, 4, 5, 6, also BSI value, MNDWI value, NDBI value, NDVI value. So all of training sample also extract the pixel value for each single point. So here you can see this point also extract the information, SRB1, SRB2, SRB3, SRB4, 5, 6, also BSI, MNWI. So all of the sample it extract the information. Okay, so you can see all of the training sample extract the information about all of bands. So this is my data set. Okay, so this is my data set training. So basically it's my data set. So this data set I want to use in my model, and then I can easily make the classification. So here you can see this is my data set Basically this dataset combination of B1, B2, B3, B4, B5, B6 as well as barren soil index MNDWI, NDBI, NDVI. So I want to add this type of external band also, and this type of band is available in my satellite images. So now how I can add this type of index, okay, in my model. For doing these things, I just use this code here. You can see I just make a function. So this is my function. So this function I want to use in here to calculate the NDVI, NDBI, MNWI, BSI. So I simply create this function, and this function provide me all of those pixel, all of those band. So this type of band further I just use here NDVI, NDBI, MNDWI, and also put here the BSI. So now it's create my data set. Okay. So further this data set I want to use and make the classification as well as also check the accuracy. Okay. So in this time you can see the full code, and if you have any confusion you can ask me, or anything if you don't know you can ask me. Any question?
It's just it's
Yeah.
just about how you collect the data set, numbers of that data set. These numbers.
Mainly 153 or 15. This is a serial number, yeah.
No, not the serial number.
Yeah. Okay, I don't understand your question, please.
Every feature class.
Yeah. Okay. You can see here. First of all, we collect the training sample, mainly water. You can see we are just collecting the training sample. Okay. Then further, we are just give a variable name and store the water. You can see water, Mars vegetation, Mars barren land, Mars urban. Okay. Simply Mars. And then when I print that, then I can get the 301. Okay. It's mainly 301 point or sample. And it also added their feature, mainly label. Here you can see it show the label is the 0. Label 0 means that it's the water. So it's my samples, it's my training samples. So now further I just use these samples and then extract this type of band pixel. Okay. So for that I just simply take a variable and call my image, select these bands, and then use this function and then call the collection. In this you can see I put here the samples because it's my stored the samples, 301 samples. And properties, mainly class, it's my property name. You can see I already put the property name is the class. So use the class, and scale is the resolution of 30 meter. And when I print that, then I can get this type of things. Here you can see it's my data set. It is the second result. Yeah. So here you can see it's this my result I can get from here. So here you can see it extract all of those band pixel value for each point. Each point is
This point.
Yes.
This number.
Yes.
0.009, 0.12. This number. I asked about this number.
Okay. So it is the band's value. It's called the spectra. Spectral signature.
Yeah.
Okay. Suppose basically remote sensing. Basic remote sensing, mainly red, green, blue, near infrared, different types of band. You can see different types of band. It give you the wavelength. Okay. Suppose here you can see we can get the wavelength value. So basically it's the wavelength value. And in this time for the water, you can see for the water value and build up value is not same. Okay. Every time, every class we can get the unique values. Suppose water and vegetation or build up or any feature in the art, we find out the unique spectral signature. It's called the spectral signature. Suppose for the barren land, I can get the another value. For the water body, I find out the another value for the spectral signature of each band. So basically, it is the wavelength. Okay, just I show you the one example. Suppose starts on the Google. It's called the spectral signature.
The electricity power is shut down here. Sorry.
So here you can see here a spectral signature. Just very simply open a page from here. You can see spectral signature used in remote sensing. There are a lot of use, not only for the land use land cover classification. We can easily use the spectral signature to monitoring the mineral, as well as also monitoring the gold detection, as well as there's a lot of use for the spectral signature used in remote sensing. So I also send you this paper. You can easily get the idea about that. So basically in this time, spectral signature, basically it's provide you the unique values of each feature, and using the spectral signature we can easily find out, or we can easily differentiate the each object. Okay, so here you can see.
Okay, fair.
Yeah.
Thank you so much. The electricity power here is shut down. Sorry for being that.
Okay, so your battery is the low, yeah.
Yeah. I will contact you on my cell phone.
Okay, no problem. Okay, no problem. If the then you can also join with your cell phone. Basically I will explain all of those things one by one. You can easily get this idea, and I also send you the recorded class also, so that's why you can also get the idea from here. Okay. Okay, can you hear me?